Today we'll be looking at another simultaneous equation, and we'll also be looking at the elimination method. We'll be looking at a particular simultaneous equation, which is 5a plus 3b is equals to 2 as equation 1, and 2a plus 4b is equals to minus 2. So we'll be solving this simultaneous equation, that is solving for a and b using the elimination method. So you have 5a plus 3b is equals to 2 as equation 1, and 2a plus 4b is equals to minus 2 as equation 2. So we're solving simultaneous equations, and in this case a particular simultaneous equation. But what do we use, or what methods do we use in solving simultaneous equations? We have several methods in solving simultaneous equations. We have the elimination, we have the substitution method, we have graphical methods, and also we have the use of matrices. But in this particular video, we'll be solving the specified simultaneous equation using the elimination method. So what do we actually mean by elimination? What does elimination mean? Just as the word implies, elimination means getting rid of something. But in this kind of question, where we have two variables, a and b, when we have two variables a and b, we can eliminate one of the variables, thereby solving for the other variable. So eliminating means getting rid of one variable and having access to the other variable. So when you have two variables and you want to solve a simultaneous equation, this can be solved with two equations. So usually the number of variables will equate the number of equations for easy solutions. So for instance, if we have 4 variables, a, b, c, and d, then we'll have 4 equations in order for us to be able to solve the simultaneous equation. But in this case, we have two variables, a and b, and we also have two equations. So what we'll just do is to look at the equation, and then we will decide which of the variables to eliminate. Remember that eliminating one variable means solving for the other. If we eliminate the variable a, that means we're going to solve for b. And likewise, if we eliminate the variable b, it implies that we're going to solve for the variable a. Now you have the simultaneous equation, 5a plus 3b is equals to 2 as equation 1, and 2a plus 4b is equals to minus 2 as equation 2. So by observation, we can decide which one of the variables we want to eliminate. Assuming we want to eliminate the variable a, what we'll simply do is to look at equation 1 and then look at equation 2. In equation 1, which of the parts of it has the A. You have 5A. In equation 2, which one has A? You have 2A. Now, how do we make equation 1 and equation 2 look alike in terms of the A's? So by observation, what we can simply do is to multiply 5A by 2, and then we have 10A. And then equation 2, we multiply 2A by 5, then we have 10A. And then we can carry out some subtraction. So we'll look at this simultaneous equation. 5A plus 3B is equals to 2, and 2A plus 4B is equals to minus 2. 5A plus 3B is equals to 2 as equation 1, and 2A plus 4B is equals to minus 2 as equation 2. Now remember, we are using the elimination method. Therefore, if we are eliminating one of the variables, in this particular case, we will start by eliminating A. It means we will be solving for B. Eliminating A implies getting rid of A. Now, how are we going to do that? So, what we'll try to do is to look at equation 1 and also equation 2. So, if we multiply equation 1 by 2 and equation 2 by 5, and then later we subtract one of the equations from the other, we'll be able to eliminate. Now, how is that possible? Now, our target is to eliminate A. So the A in equation 1 must look like the A in equation 2. In equation A, we have 5A, but in equation 2, we have 2A. So what do we do in equation 1 to make it look like equation 2? And what do we do in equation 2 to make it look like equation 1? That is in terms of the A. So in equation 1, what we'll do is multiply it by 2. And that's why you have 5A times 2 is equals to 10A. And then in equation 2, your 2A, what do you multiply it by? You multiply it by 5 in order to have 10A. So in that way, we'll be able to subtract from each other and then eliminate A. So to eliminate A, we'll multiply equation 1 by 2 and then multiply equation 2 by 5. Remember, we're going to be multiplying each of the components by the referenced factors, after which we'll carry out subtraction. So let's look at the simultaneous equation and then carry out the advised multiplication based on our observation. So times 2 above of the equation 5A plus 3B is equals to 2. So when we multiply 5A plus 3B equals to 2, we'll be multiplying each of the components by 2. So if we multiply 5A by 2, what are we expected to get? We're expected to get 10A. If we multiply 3B by 2, we should get 6B. And if we multiply the constant on the right hand side, number 2, by 2, we will get 4. Now, going down to equation 2 times 5 means we are multiplying equation 2 by 5. So we'll be multiplying each of the components by 5. So we have 2A times 5, we will get 10A. and then we'll also multiply 4b by 5, and then we'll get 20b, and then the constant on the right hand side minus 2, we will multiply it by 5, and that should give us minus 10. So let's see what we will get by the time we carry out this multiplication. So just like I said earlier, we are multiplying equation 1 by 2, and that's what we get on the right hand side. We have 2 multiplying 5a to give us 10a, and then we have 2 multiplying 3b to give us 6b, and we have 2 multiplying 2 to give us 4 on the right hand side, and that gives us the new transformed equation, which is now called equation 3. And then if you look at equation 2 on the bottom left, we are multiplying 5 by each of the components, and then we now have 2a times 5, which gives us 10a on the right hand side, and then we have 4b times 5, which gives us 20b on the right hand side, and then we have the constant minus 2 multiplied by 5, and that gives us minus 10 on the right hand side. So equation 2, by virtue of the new multiplication, has been transformed from 2a plus 4b is equals to minus 2 into 10a plus 20b is equals to minus 10, and is also renamed as equation 4. So we have two new equations, equations 3 and 4. So looking at equations 3 and 4, how do we solve for b? So we will be eliminating a. We have succeeded in making the a's the same so that we can eliminate by subtraction. So what we'll do is we will say equation 4 minus equation 3. Equation 4 minus equation 3. So to eliminate a, we will have to carry out equation 4 minus equation 3. So what we do is that in equation 4, we look for the similar components we have in equation 4, and then similar components in equation 3, that is the like terms, and then we carry out the subtraction. We have an a term in equation 4, and we have an a term in equation 3. So the a term in equation 4 is 10a, and then the a term in equation 3 is 10a. So we have 10a in equation 4 minus 10a in equation 3. So also in equation 4 we have a 20b, and then in equation 3 we have 6b. So since we're subtracting 3 from 4, that is 4 minus 3, it will be 20b minus 6b. So on the right hand side we have the constant terms. So we now have is equals to minus 10, that is in equation 4, subtracting the constant term in equation 3, which is 4. So minus 10 minus 4. So if we simplify this further, 10a minus 10a will give us 0. 20b minus 6b will give us 14b. And then minus 10 minus 4 will give us minus 14. You're owing 10, and then you're owing another 4. In total, you'll be owing 14. So that's minus 14. So if we simplify further, we'll see that the a terms have been eliminated. So that is where the elimination method comes, converting the initial equations to such a way that a certain variable can be eliminated, thereby paving the way for another variable to be solved. In this particular case, we have eliminated a, And that's why we have 10a minus 10a, which now becomes 0. And we have paved the way for our b to be solved. And that's why you have 20b minus 6b, it becomes 14b. And on the right hand side, you have minus 10 minus 4, which is equals to minus 14. Therefore, if we simplify, we have 14b is equals to minus 14. 14b is equals to minus 14. In order for us to be able to solve for b, we'll divide both sides by 14, thereby cancelling out the 14 on the left-hand side and then dividing also by 14 on the right-hand side for us to be able to simplify. So what we're simply doing is dividing both sides by 14. So 14b over 14, that will give us b, and then minus 14 over 14, that will give us minus 1. So we've been able to solve for b. Our b is minus 1. In the previous slide, we eliminated the variable a, and after eliminating a, we solved for b, and b is equals to minus 1. So let's look at the simultaneous equation once again. 5a plus 3b is equals to 2, and 2a plus 4b is equals to minus 2. So this time around, we will be eliminating the variable b. We will be eliminating the variable b, thereby paving the way to solve for the variable a. What do we mean by elimination? Elimination means getting rid of. In this particular case, we want to eliminate the variable b so that we can now solve for a. Now, how do we go about doing this? Let's look at the terms that have b in equation 1. Likewise, we also look at the terms that have b in equation 2. In equation 1, we have 3b. In equation 2, we have 4b. How can we come about a term that has the same look in equation 1 and the same look in equation 2 in terms of b? What we can do is, looking at equation 1, we have 3b, and in equation 2, we have 4b. So what we can do is, what's the lowest common multiple between 3 and 4 is 12. So in equation 1, we can simply multiply 3b by 4, and equation 2, we multiply 4b by 3. If you multiply 3b by 4, what do you have? 12. And if you multiply 4b by 3, you have 12. That is 12b. So when you multiply the coefficient of b in equation 2, that is 4, by 3b, you have 12b. And if you multiply the coefficient of b in equation 1, that is 3, by the b factor in the b component in equation 2, that is 4b, if you multiply by 3, you have 12b. So what we just simply do is, we multiply equation 1 by 4, that is all the components, and then we'll multiply equation 2 by 3. And then what we'll now do is to subtract one of the equations from the other in order to eliminate. Now let's look at this. When we multiply equation, the b component in equation 1 by 4, what do we have? We have 3b times 4, which is 12b. And if we multiply the b component in equation 2 by 3, we have 12b. So that's the whole idea, having the same look in terms of b in both equation 1 and 2, so that we can subtract them from each other, thereby eliminating. Note that when we multiply by 4 all the components in equation 1, we are doing that in order to achieve this purpose of having the component of b in equation 1 similar to that of the component of b in equation 2. And that's why in equation 2 we multiply the components by 3, so that we have 4b times 3, we have 12b, and then all the other components too in equation 2 are multiplied by 3. Let's see how this works. Let's see how this works. So this is the equation. 5a plus 3b is equals to 2. And then we have 2a plus 4b is equals to minus 2. Those are equations 1 and 2. But what we've said is that we'll multiply equation 1 by 4, and then we'll multiply equation 2 by 3. Now when we multiply equation 1 by 4, we're multiplying each and every one of the components. So 5a times 4 gives us 20a, as we can see on the right. 3b times 4 gives us 12b, as we can see on the right hand side. And then the constant 2 multiplied by 4 gives us 8, as we can see on the right hand side. And then let's go to equation 2 below on the left hand side. We're multiplying it by 3. 2a times 3, we have 6a. 4b times 3, we have 12b, as we can see on the right hand side. And minus 2 times 3, we have minus 6, as we can see on the right hand side. So we now have equations 5 and 6. We are calling it equations 5 and 6 because we don't want to repeat any other numbering that we've had in the previous solution. So now that we have a transformed equation, equation 5 and 6, we can simply say equation 5 minus 6. Equation 5 minus 6. So when you look at the components, we'll be able to eliminate the b component. When we eliminate the b component, then we'll pave the way for the solution to equation and the a variable. Subtracting 5 minus 6, equation 5 minus 6. What we do is look at each of the components. So the a component in equation 5 is 20a. So if we subtract this a component in equation 6, that is 20a minus 6a. Then the b component in equation 5, that is 12b, subtract the b component in equation 6, that is 12b. So that's why you have plus 12b minus 12b. And then looking at the constant term in equation 5, we have 8. And looking at the constant term in equation 6, you have minus 6. So we say 8 minus 6. So when we simplify further, we have 20a minus 6a, which is 14a. 12b minus 12b, which becomes 0, and that is demonstrated by us eliminating the b. And then 8 minus 6, the minus and the other minus becomes plus, because minus times minus is plus. So we now have 8 plus 6. So in simplification, we have the a term reduced to 14a, and then the b term eliminated to 0. And then the constant term on the right hand side, we have 8 plus 6. At the end of the day, we have 14a is equals to 14, and then a will be 1, because if we divide both sides by 14, we will have a on the left hand side and 1 on the right hand side. So we've solved for a is equals to 1 and b is equals to minus 1. We can do a quick check. We'll look at equation 1, where we have 5a plus 3b is equals to 2. And then we quickly substitute the values of a and b in those equations. So we're looking at equation 1. So we have 5a plus 3b is equals to 2. So 5a plus 3b, wherever we see a, we put 1. And wherever we see b, we put minus 1. So 5 into 1 plus 3 into minus 1, which is simplified as 5 minus 3. And 5 minus 3 is equals to 2. And that satisfies equation 1. So that tells you our a and b are correct, satisfying equation 1. A is equals to 1, b is equals to minus 1. But we don't want to assume it. We will also check to see that if that also works for equation 2. So our equation 2 is 2a plus 4b, and that should give us minus 2. So we'll substitute. Anywhere we see a, we'll put a is equals to 1, and anywhere we see b, we'll say b is equals to minus 1. So 2 into 1 plus 4 into minus 1. So we have 2 minus 4, and 2 minus 4 is minus 2. So our solutions, a is equals to 1 and b is equals to 1, satisfies both equation 1 and 2. Therefore, our answer, a is equals to 1 and b is equals to minus 1, are both correct in this elimination method. Thank you.